cyclotron. The alpha and beta particles given out by natural radioactive substances neither possesses sufficiently large speed nor their speed are under control. It was therefore felt necessary to accelerate. Okay, the alpha and beta particle gives out the natural radioactive substances neither possesses sufficiently large speeds nor their speeds are under control. It was therefore felt necessary to accelerate. Okay, charged particles to very high velocities by the application of electric and magnetic field. Okay, Kraft and Walton produce fast-moving proton by electronic voltage multiplication device. The best arrangement was, however, made by Lawrence and Livingston in 1934 and is called cyclotron. Okay, this arrangement won the Nobel Prize for Lawrence. Okay. Charged particles to very high velocities by the application of electric and magnetic fields. Okay, charged particles to very high velocities by the application of electric and magnetic fields. By the application of electric and magnetic field, okay, Kraft and Walton produced fast-moving protons, proton by electronic voltage multiplication. By electronic voltage multiplication device. Okay, the best arrangement was, however, made by Lawrence and Livingston. Made by Lawrence and Livingston in 1934 and is called a cyclotron. Okay, this arrangement won the Nobel Prize for Lawrence. Okay, construction. This cyclotron consists of two D-shaped hollow metal segments. D1 and D2. Okay, the cyclotron consists of two D-shaped hollow metal segments D1 and D2. Called the dish. disk, called the disk. Okay, lying in a horizontal plane with a small gap separating them, a magnetic field Ns. Magnetic field Ns. Okay, magnetic field Ns is applied perpendicular to the plane of the paper, and D1 and D2 are connected to a high voltage frequency. Okay, D1 and D2 connected to a high voltage frequency alternating current as shown. Okay, then role of the electric and magnetic field. Role of the electric and magnetic field. Role of electric and magnetic field. Okay, simultaneous application of electric and magnetic field plays an important role in the construction of cyclotron. Okay, electric field. Okay, the primary function of electric field is to provide a potential difference between the D's of the cyclotron to accelerate the charged particles. Thus, an alternating electric field having a frequency such that the time taken by the particles to travel through the semicircular path within the disk is equal to half the time period of the alternating electric field is required. Okay, magnetic field. The primary function of the magnetic field is to move the charged particles into a semicircular path within the disk. Okay, principle. The electron is a magnetic resonance type positive ion accelerator. The cyclotron is a magnetic resonance type positive ion accelerator. The charged particle to be accelerated placed at center point P of the disk rapidly passes through an alternating electric field along a closed path, its energy being increased each time. Or strong magnetic field is used to control the motion of the particles and to return them periodically to the region of the accelerating electric field. The particle passes the finite point of the alternating electric field almost in unison when the field is in the same phase in resonance. Okay, resonance condition. What is resonance condition? As we have discussed above, cyclotron is a resonance device. In a cyclotron, the value of the magnetic field magnetic field strength depends upon the frequency of the oscillating electric field applied between the disks. It is so chosen as to give resonance between the arrival of the charged particles in the gap and the reversal of the voltage between the disks. This is done by adjusting the time taken by the charged particles to describe a semicircular path equal to half the time period of the oscillation of the applied high frequency electric field. Okay, then pi by omega equal to T by 2. The frequency F equal to 1 by T, that is omega by 2 pi, that is BE by 2 pi M. BE by 2 pi M. Okay, this And this gives the cyclotron resonance condition for charged particles of a given value of E by m. Okay, this gives the cyclotron resonance condition, cyclotron resonance condition for charged particles of a given value of E by m. Okay, if this condition is not satisfied, there will be no resonance between the arrival of the charged particles in the gap and the reversal of the voltage between the disc. This particle will go out of step and will not be accelerated. This is why it is said that a cyclotron is a resonance device. Theory and working. Next point, theory and working. Theory and working. Theory and working. Okay. Theory and working. Okay. 1 minute. Theory and working. If a positive ion is generated at a point P, 1 minute. You wait just for 1 minute, okay? You wait just for 1 minute, okay? Line. Okay, and this is point P. This point is P, and this is AC, alternating current, and high frequency alternating potential difference. This is high frequency alternating potential difference. Okay. This is target. This is target. Okay, and this D1, this D2, and this W. Okay, P and C. Okay, then theory and working. Okay, theory and working. If a positive ion is generated at a point P as shown within the gap at a time when D1 is at a positive potential. D1 is at a positive potential when D1 is at the positive potential and D2 at the negative potential. D2 at the negative potential. It will be accelerated across the gap to D2 and enter the hollow segment D2 with a velocity v given by Vt equal to 1 by 2 mv square, where V is the applied voltage, and E and M are charge and mass. E is the mass is the charge, and m is the mass. Okay. Then mass of the particle respectively. When it is inside the conductor, it will not be acted upon by the electric field, but under the influence of the applied magnetic field having a flux density b. It will travel along a circular path, the radius r of which is given by mv square by r equal to BeV, then r equal to mv by be. Okay, and finally emerges at c in the direction indicated. The time taken by the positive ion to travel the semicircular path. Then t equal to pi by omega equal to pi r by v equal to pi m by be. Okay, then time equal to pi by omega equal to pi r by v equal to pi m by be, where omega is the angular velocity of the ion in the circular path and omega equal to be by m. Okay, the value of t is a constant being independent of the velocity. Okay, the value of t is at constant being independent of the velocity of the ion and the radius in which it travels. If the frequency of the applied voltage is adjusted in such a manner that it is reversed as soon as the particle comes out of the D2, the particle at C will be accelerated across the gap to D1 and will describe a further circular path in D1. Okay, further circular path in D1. The radius of this semicircle as well as speed of the particle will now be greater than that in the first case, but as proved above, the time taken by the particles to travel the semicircular path in D1 will be the same. Every time the particles emerges out of the disk, the direction of the voltage is reversed and the particle is accelerated across the gap. The path of the particles will be a spiral, and it will finally come out of this in the direction indicated through the window W. Okay, window W. Okay, maximum kinetic energy of the particle. Maximum kinetic energy of the particle. Maximum kinetic energy of the particle. The final energy of the particle is maximum kinetic energy of the particles. Maximum kinetic energy of the particles. The final energy E of the charged particle is given by E equal to 1 by 2 mv square max. Okay, where v max is the maximum velocity gained by the charged particle in its final orbit of the radius r max. Okay, then mv square max upon r max equal to bev max. Then Vmax equal to VE by M R max. Okay, and so E equal to 1 by 2 MV square max. MV square max equal to 1 by 2 M V square E square by M square R square max. Okay, then this is 1 by 2 V square E square R square max upon M square. Okay, upon M. Okay? Then this relation gives the maximum kinetic energy of the charged particle in terms of applied magnetic disk radius. The condition for the optimal acceleration of the ion in this gap is that the time taken by the ion to travel the semicircular path T is equal to half the time period capacity of the oscillations of the applied high frequency electric field. Then T equal to capital T by 2 R pi m by dE equal to capital T by 2. Then T equal to 2 pi by m upon dE. Okay? If F is the frequency of the oscillating electric field, then F equal to 1 by T equal to BE by 2 pi m. This is the basic cyclotron resonance equation, and in terms of F maximum energy of the charged particles, Emax equal to 1 by 2 B square E square I square max upon M. Then Emax equal to 1 by 2 4 pi square M B square E square by 4 pi square M square R square max. Okay? Then Emax equal to 2 pi square M F square R square max. Okay? Then the particles are ejected out of the cyclotron. The particles are ejected out of the cyclotron as a pulse streams and not continuously, with a comparatively small potential difference of the order of 50,000 volts. Very fast moving particles can be produced. For example, if a particle makes 200 revolutions before merging out, it will gain a velocity equivalent to a total fall through potential of 2 multiplied 50,000 multiplied 200. That means 20 million volts. Okay? If heavy hydrogen is used instead of ordinary hydrogen, a beam of high energy neutrons is obtained. As their mass is double, they possess greater energy and are more useful as atomic projectiles. Okay? Maximum radius of curvature. Next, maximum radius of curvature. 1 minute. Maximum radius of curvature. 1 minute. Maximum radius of curvature. Maximum radius of curvature. Okay? If capital V is the average voltage applied between the disc of a cyclotron and the charged particles crash the gap between the disc n times to reach the orbit of the maximum radius, then energy acquired by the ion having a charge E is given by Emax equal to NeV, then but Emax equal to 1 by 2 B square E square R square max by M. Okay? Then B square E square R max square by 2M equal to NeV. Okay? Then R max equal to 1 by B 2mv by E power whole to the power 1 by 2 and to the power 1 by 2. If the value of B and V are kept constant R max is directly proportional to the square root of the number of the times the particle cross the gap between the disks. Okay? Limitation of the cyclotron. Limitation of the cyclotron. Cyclotron. Limitation of the cyclotrons. Okay? First, energy to which a particle can be accelerated in a cyclotron is limited due to charge in mass with velocity. The mass of a particle when moving with a velocity v is given by m equal to m naught upon under root 1 minus b square upon c square, where m naught is the rest mass. Where m naught is the rest mass. Rest mass. M naught is the rest mass, where m naught is the rest mass and c the velocity of light, and c the velocity of light. C the velocity of light. As already proved, the time taken by a particle to travel the semicircular path is pi m by b equal to t by 2. Frequency f equal to 1 by t, that is be by 2 pi m, then that is be under root 1 minus b square by c square upon 2 pi m naught. As the frequency of the rotation of the charged particles decreases as the velocity increases. As a result, it takes a longer time to complete its semicircular path, and the particle continuously goes on lagging behind the applied alternating potential difference till a stage is reached when it can no longer be accelerated further. This discrepancy is optimized by the following two methods. First is field variation. First is field variation. The frequency of the ion can be kept constant by taking b under root 1 minus b square by c square constant. For this purpose, the value of the magnetic field B should be increased as the velocity of the ions, so the product remains unchanged. Second point, frequency modulation. Okay? In the alternating method, the frequency of the applied AC is varied so that it is always equal to the frequency of the rotation of the ion. The machine in which the frequency of the electric field is kept constant and magnetic field is varied is called a cyclotron. Whereas the machine in which magnetic field is kept constant and the frequency of the applied electric field is varied is known as frequency modulation cyclotron or cyclotron. Okay? Second point. A cyclotron cannot be used to produce high energy electron beams. The reason for the same is that there is an appreciable increase in the mass of the electron at a fairly low energy. For example, a 10% increase in the rest mass of the electron takes place at an energy of 50 kiloelectron volt only. Electron being a very light particle, so there is an appreciable increase in its velocity at low energy, which is not the case within the massive particles like the proton or the alpha particles. Third point. Neutron cannot be accelerated by a cyclotron. A neutron carries no charge. It cannot be accelerated by the electric field between the two disks. It can also be not acted upon by the magnetic field, so that its path within The disk cannot be regulated. Next, magnetic field focusing. Magnetic field focusing